what are you going to get out of today? You're going to give me your lunchtime. I appreciate that. Um, Maybe you're noshing away a little bit right there. I'm going to do the same in a little bit after we finish here. I won't. So this quick introduction, just kind of what Python is. So those of you who didn't raise your hand about, hey, I've worked with Python before, that's okay. That's exactly where you need to be. I'm just going to give a 80,000 foot view. There you go. Pardon the cliche. And then a quick survey of some of the Python libraries, specifically the data science libraries. And that's the hard part. There is a plethora of these out there. It's kind of like, the old cliche from Apple used to, there's an app for that. Well, there's a library for that. Yes, Corey, I see a question. What's up? Or are you just clicking buttons? Or a little bit of both? Nothing, any questions? Oh, hands. Nice to meet you. There we go. Thank you. Okay. No problem. So pardon me there. It takes me a second I have to adjust the view on the little control panel for GoToWebinar. And I have to be honest, I've spent probably 99% of my time in Zoom meetings, as many of us may have, or Teams or something else. And each one is slightly different. There you go. No problem. Feel free. You can all jump in. I'll try to keep that panel open. It has a really annoying tendency that if you don't, it closes. It only lets you have one panel open in the control, but that's my problem to worry about, not yours. All right. So like I said, we'll get an overview of some of the data analytics, data science pipeline. And because really that's what everybody wants these days. They want to build that machine, right? They want to build, I've got to bring in these raw data sources and I'm going to move slowly but surely till I get answers, till I get answers to questions. And then of course, this is from WebAge. And so we're going to tell you about some other places you could go to. Or at least I love building roadmaps with folks, whether that's with our particular courses or not. I'd love to see you in another course, whether that's in person now. We're starting to get back to in person for some of this, or online. I love doing the online in my little COVID bunker studio that I'm in right now. So feel free. Anyway, let's get to some of the meat here. So just an overview of where we're going for each one of these. We're going to talk. Come on. Start to move. So we'll look at the Python data science libraries. I'm going to look at some tools here. So let me just throw out some real quick here. How about is Jupyter? Can't ring a bell with anybody. I bet you. Wait. Hold on. Let me back that up a second. How about Excel? There's always an Excel person, and if you're an Excel person, that's great. You can do a lot of stuff with Excel, and that might be a question as we go through this hour here of, well, why would I do this instead of just I can. I'm pretty good. As a matter of fact, there's a whole book, one of my favorite books called Data Smart, that gentleman essentially wrote how to do a lot of the analysis that I do with Python, how to make it happen in Excel. I think it was more of a personal challenge for him. And so we can talk about, there are some limitations with Excel, right, as we go through here. So we'll discuss tools and process, and I have some demonstrations here and there. They're not, too in depth. They're more just to kind of wet your whistle on this and try to give you an idea of what to do. All right. So first of all, Python. Probably if you're here, you're probably aware of Python, and if you're not, so open source, free. You can general purpose. I like to joke. Anybody a Java developer? Do I have a Java one on here? I have Java folks come on board here. I have done some programming maybe at some point or college along those ways. And if you try any of these, so Java and Python, I like to joke that Python can do anything Java can do. We just do it in 1/10 of the lines. That's about it. So it's not it's a fairly simple language, and it's becoming, if you take a computer science degree, Java used to be the thing, and when I started, because I'm old, don't you know? When I started, it was C, and so we worked with C, and then we got things like Python and Java came along. It was a revelation to suddenly do a lot of things. I don't have to manually take care of memory. Okay, all right, but it is an interpreted language, and what that means is just like Java, those who use the Java application, you need some runtime, essentially a program, to interpret the instructions that you write. And so that's when we get to tools. That's where things like Jupyter or Python. I use a lovely tool called Data Spell that are essentially a program to run your program. How's that? All right. But that style, there you go. Yeah, I see. You know, oops, did I miss a question? Actually, let me do this real quick. Here we go. Because it doesn't want to. There we go. All right. So it supports these different. Sorry, so I always had a question there, and as I said, I have to switch the gears real quick on it here. No problem. This idea of imperative, object-oriented, or functional. Let me just translate that for a second here. If you touch Java, which I asked about a few, then you've seen object-oriented. Everything is an object. You define something called a class, and everything is defined within that class, and you make methods for that class. Methods are things it does. But if you're, I'll ask this one, and I can't see all your lovely smiling faces and so on, so I never know, where you are in your life here and what you've been with. But when I started, the first thing I touched was something called BASIC. That dates me definitely. Beginner's all-purpose and instruction code, and essentially it is very imperative. It says you say what to do. Print this. Go to this line. Yeah, they dreaded go to. Do this. Do this. Do this. Do this. It's all instruction. That's that imperative model. And so we kind of like that in data science because we can do this in an exploratory way. So when we talk about exploratory data science or exploratory data analytics, what we're looking at is, okay, let me ask a question, try a few lines of code, let that change things for me. And what's the new state of my data? So we'll get to this idea. All right. But really, probably the bigger one. So Python itself, and of course, if you wanted to get Python, have this here. You could always just go to python.org. What you have to understand is that Python, however, so this is your starting base, right? Go grab your copy of this, Mac, Windows, Linux, whatever you want here. They also have, if you're wanting to learn, of course, we will teach you Python, but they have a great, documentation tutorial. I find that that's a lost art to read documentation. But they're very good at putting this all together here. But you can see on the left-hand side there, you see some examples of just what Python code looks like. It's terse, right? It's very short. It's simple to work with here. All right, so that's your first step. When we're making our roadmap of where to go from here, you just want to be comfortable with Python. You don't have to be a guru. You don't have to be an expert. But then I can move you to the data science arena. How's that? The second thing, which I don't really have a slide for here, is that yes, knowing some of the math is okay, but I've got some good news for you. And the good news is that most of the algorithms, or in other words, the steps, the calculations you would do in the math world, are already written into libraries. So let's break this down here. I'm going to talk about the way Python is organized. And there we go. Come on. All right, switch gears again. Too many windows, not enough monitors. 2 monitors, but still not enough. I need like 3 or 4, like a big, operating center there. All right, so just to kind of put it together here, when you store data in the computer, we're going to get through this very quickly because we want to get to, the data science stuff. When you put data into your computer, when you type anything, it's got to get stored in, you've probably heard RAM, it's got to get stored in memory somewhere, and eventually gets stored in persistent storage. That's your hard drive. Okay, this is all probably for most everybody here. Yep, basic, got that. All right, most programming languages divide up how that memory is sliced and diced and how they determine what can go in a particular section of memory. And they do that, we call that a data type. Right? That's really what a data type is for most languages. So if you've been with any other language, in whether that's Java, Ruby, C++, C, Perl, whatever, Bash for that matter, you can set up different variables that refer to different data types. In Python, these are them. You pretty much have 2 broad categories. You have single data types, singular things like an integer is what that first one is, int. A float, meaning, so an integer is a whole number. Float, meaning a number with some fractional part to it. And bool, essentially, is something true or false. And we actually do have a separate data type just for that. Some languages cheat a little bit and they use 0 or 1. And again, I'm not trying to teach you Python in like 5 minutes, but it helps to have some of this background before we talk about some of the other things in there. But usually most of us find that trying to deal with just singular data, that's not enough, right? So we put them in a collection. And the one that's kind of strange here is the first one's a string, all right? My daughter used to have this little necklace that had her name on it in little white squares. So a bunch of characters, right? Her name. You put a bunch of characters together, you get a string. They don't have to be just letters. They can be numbers, symbols, spaces, punctuation marks, even non-printing characters. That's all a string as far as Python is concerned. And a string is treated as a unit, but even a single character can be a string. And some languages differentiate between that. They treat a single character differently than they treat a bunch of characters. All right, so Python C, you can see where this got simplified a little bit. All right, so Guido van Rossum is who we blame for creating Python. He's Dutch, so anybody Dutch? Checking. I like to blame a lot of things of why we do things in that way as well. It's because he's Dutch. It makes sense if you're Dutch, I guess, is sort of the go-to. But calling it a string and not having a single character or an array of characters in other languages works. So a list is just that, just a list of things, and they don't all have to be the same data type. That's also a powerful tool. In other languages, if you're my C or my C++ person, you might know, or Java for that matter, you might know of an array. An array has this rule. You always need that same data type. If I make an array of integers or array of floats, every single element is going to be a float, or every single element is going to be an integer, right? So a list, but doesn't care. You could have a character, then a string, then a variable that represents some other object, then a float, then any other, a list inside of a list. It doesn't care. It will just hold them all and keeps them in order. It's a container. It's like a big Amazon box, where you got everything in a bunch of other little boxes in it. The tuple, on the other hand, right, is like that box, except you can't change what's in it. Once you put stuff in the box, that's the set. See, it's similar to the set. The set, every item needs to be unique. So it's a collection again. So you could have a set of integers, right? And if I gave you 1, 1, 2, 3, what you would end up with is a set of only 1, 2, 3. The set doesn't allow duplicate elements. Dictionary is when we put keys and values together, just like in a dictionary where you have a word, then you have a definition. Typically, the key part to find the value is the key part is typically a string, but it doesn't have to be. It just has to be anything that is unique. So you can think of it this way: a dictionary is actually a fancy kind of set. It's a set where all the keys are unique. The values can be the same. So you could have two words like run and walk fast, maybe, and those are two different keys, but they mean the same thing as far as you're concerned in the dictionary. And the last one is bytes, which is pretty unusual. What you're really doing is just telling the computer to look at this collection of memory locations and don't worry about trying to turn them into something human understandable. They're just zeros and ones as far as I'm concerned. So that's really getting a little under the hood there. Okay, now that was a little bit of a deep dive if you're brand new, and it might have been a little bit like, well, what? Okay, if you're a programmer, you're like, I hope my programmers are going, yeah, gotcha, I'm right with you. I understand what it is. Only thing I need it for is just to kind of set the groundwork, right? So there is yet one more way to gather things together. So you have two things you have to worry about when you write a program. So we're going to use Python for data science. We're going to write a program that does it. One is the data. So this is our containers, right, that can hold data. But we also have ways that we can contain code, contain instructions would be the best way to think about it. And these are some things that are slightly unique to Python as well. Most languages have something called a function. And a function is simply a magic machine. You feed it data in, it does some magic, and you get different data out if you want. The out part's actually kind of optional. Sometimes it's just a transform. It just changes what the data is. And so it's always the same. It's like in math class when you learn functions, when you start to go into algebra, right? If you give it x, it will give you y. F of x equals y, right? That's essentially what a function is in code. And they can be really long, really short. They can be simple. They just put things on the screen. For example, print is a function in Python. You say print these characters, it puts those characters on the screen. See, the input is this, it does the action. There is no extra output that you need. It gives you no, as we say, return value. It gives you nothing back. All right. Generators, on the other hand, And I usually get asked, well, so they're basically functions, but they're functions with a little magic step to them. Essentially, if you want to, so I work in, or have worked in security quite a bit. And one of the things that we like in security is we like cryptography so that we can hide and encrypt things. And the thing about cryptography is that we love to work with large prime numbers. So those are hard for you to figure out. If my magic password, imagine like maybe you've got those little TSA locks on your luggage. Imagine if my TSA lock code was a 400 digit long prime number. You probably wouldn't randomly guess that, you know. But I know what that prime number is anyway. We like to get prime numbers. There's lots of reasons. All right, so if I were to create, remember, we need to store data in memory when we run this. If I were to create a list of those prime numbers, well, it's infinite. How big? I'd have to decide eventually that, I've only got, maybe 4, 8, 16 gigabytes of RAM on my computer. I'm not going to fill up all the memory on the computer with just a list of numbers so that I have them. If you are a Wi-Fi user, you are using prime numbers right now to encrypt the data between your Wi-Fi router and your laptop, desktop, what have you. And that Wi-Fi router uses a number of different keys that are basically 2 to the 256th power. Now, if you do that, that's a really big number. I don't even know what you call that. So you can try that in your calculator, type 2, and then use the little exponent button and type 256, and you'll see a really large number. Imagine trying to store all those different numbers in your computer's memory. It wouldn't happen. So what a generator does is remember where you left off. If there's a pattern on how you can get to the next one. So for example, I can always keep searching for the next prime number. Well, a generator says, okay, I gave you prime number X. Next time you come in, I'm going to give you prime number X1, X2, X3, X4, but I won't keep them all in memory. I'll give them to you as you ask for them. So you're storing the instructions in memory, not the data. Sneaky. And if you think about it, it's when someone asks you, when's your next available empty slot for an appointment? You don't store every hour in your head of when you're available. You just go, let me look at my calendar and look for the next. So generators are really useful, and a lot of behind the scenes that we work with in the data science libraries are doing just that. They're looking for the next. A class is to turn something into an object. Essentially, when you hear class, think your own custom data type. A module, I'm going to blame Guido. All right. See, when Guido says, Guido is Dutch. So you say file, I say file, Guido says module. It's a file of code. That's it. It usually has a .py extension. And then last but not least is the package. All right. And the package, again, I'm going to blame Guido. One Russell, he's Dutch. Guido says package. You and I say folder or directory. Same thing. Put a bunch of modules and other packages in one spot, one folder, call that a package. That's it. There you go. Which brings us to, okay, probably the real meat of why most of you are here is like, all right, that's great. We got this lightning crash course on just some background about Python, and we can get to this. So I showed you where you could go to python.org, and you could download Python. The neat thing about Python is because it's open source and Guido basically gave it to the world for free, anybody else can make essentially an add-on to it. All right. And we'll call these as libraries. They are essentially just packages of code. All right. And there are some very popular ones. And once you start going into this arena, you're going to find hundreds and hundreds of them. There are all kinds. And so that's going to be half your battle is figure out what do I use. So I'm going to give you a little bit, kind of little roadmap of some of these here. So NumPy, and just again, we'll put them, the first thing people usually do is they go do something like this. They go Google like the site and here. So here's NumPy, and you're like, well, that's really helpful. You see this phrase that says powerful n-dimensional arrays, right? And you go, and I see a question too. That question is just practice. What's up? Was it Abul? All right. Am I missing it in the? No? Feel free to unmute too if you'd like. Oh, okay. Kind of hard. Are you allowed to? Can you? There we go. If you have trouble with the mics, I think I have it that everyone's. can do their muting, but if not, all right. Maybe it was you were just clicking. All right. So either way, I'll be short with this. There you go. Not interesting. Okay. Yeah, feel free. I'll keep an eye on the questions and try to get there. I'll open up the mics at, after I gab a little bit, we can chat that way too. And you're welcome to get hold of me after the fact if we miss anything along the way. All right, so you look at this and you go, okay, all right, NumPy. It's basically code. You notice that. So it's going to need to be, in order to use this, to use somebody else's code, I need to get it onto my machine. All right, just like if I'm going to use somebody else's chapter, we're writing a book on, I don't know, butterflies, and you're going to write the chapter on their migration. I'm writing the chapter on how much are they moths or not. And so if I want to get it all together into one, I'm going to have to import yours into mine, right? Or the other way around, if you're going to collect the whole book together. For this process, right, you notice with NumPy, right, let's break these down a little bit. So we have NumPy, which is the first one. There we go. And essentially an ND array is kind of like a more powerful Python list. So basically everyone went to, we created this data type, and I'm going to show you some code here in just a second here. And essentially this is the building block of most machine learning out there, most machine learning libraries. It holds the data in as many dimensions as you need. That's what the ND stands for, n-dimensional array. But listen to that word array. Python didn't have a data type called an array. All right, what an array is, it's kind of funny, we've gone full circle. All right, in C, you create an array. An array is a collection of elements. Those elements are all of the same data type. For example, you would make an array of integers, or an array of floats, or an array of characters. Yeah. Anything we were missing? What was this? What do you mean? Oh, did it not, the slide, NumPy? You don't see where it says NumPy ND arrays are more like Python list? Is it not sharing with you correctly? Let me try this again. Where's the sharing? Show screen on monitor 2. You can see that? Good to go. Okay. Just a timeout every now and then. All right. So, no, this is just a NumPy. Here we go. You're stuck on the welcome page. That's very strange. Let's see. It should be going. Let me back up the truck then. Okay, no problem. We can fix this real quick. Let me see. Okay, there we go. I got it. Yeah, it's for some reason it was not. We'll just back it up real quick. Okay, that's interesting. Stayed on the welcome. I apologize. All right. Well, all of these. This is what you may have missed. I apologize. Either way, so it will be there for you in the slide set. Essentially, just summary of what I was just talking about there. The different data types, the collections. We'll break it down. No problem. Okay. Now it seems to be moving good. I don't know why it was paused, but it was just not moving along. There you go. Yeah, it also keeps taking me off. We'll notice that it tries to mute me randomly. But I apologize. If you have trouble, I'll keep an eye. I finally got my questions window open, working just fine too. So the custom collections of code is really what we're looking at. We're looking at taking base Python, and these are the data science libraries that you want to concern. So your roadmap is first, number one, you want to be comfortable. You don't have to be a guru, but you want to be comfortable with Python. Then the next one is to learn the various data science libraries, the extras, the add-ons. Now, these are from different organizations, not from Guido and team. They're from other programmers who have put together these libraries. And we're going to pick apart some of these. I'm going to show you some code examples in just a second here. Those libraries, they do need to be installed on your machine or whatever tool, if it's a server-based system that you're using, on that server that you're using. They're free and open source, the ones I list here. These are not the only ones. But what you see on the screen is a rough order that you might want to become familiar with them. There are some things that might change, like the two in the middle. There's one labeled scikit, learn, and scipy. Those two, you might jump over a little bit and just do some, because you want to get to the last two, matplotlib and seaborn, which are more for visualization. So everybody's going to have a little niche where they're going to go as they're working through data science. But let's take a look at NumPy. This is what I wanted you to see there, was that I was comparing it to that list. That list in Python can hold anything, any data type. In NumPy, an ND array can be any dimension. So it can be a list, one dimension if you want to think of it that way. It can be like a table, 2 dimensions. It can be like a cube, 3 dimensions. It could be like 4 dimensions. I don't know how to describe a tesseract. Is that what you call it when you got 4 dimensions? It can be in numerous dimensions. And all of those, okay, dimensions there can hold single elements. Each intersection can hold a single element of data of all the same data type. So you could have a cube of integers, or a table, an ND array, so a 2D array of floats, if you will. All right. And so that data structure, though, is how we started to build other libraries. But like I said, so remember, the key takeaway is ND array, one data type, that's it. All right. It's also got this library is full of mathematical functions for ND array. So in other words, basic statistics. You want to do some math, you want to find out means and modes and standard deviation and so on and all that, classic things like that. Quick and easy. But remember, I said I worked in security. One of the things we like in security, we like randomness, right? Or if you work in probability, if you're trying to do things like predict stocks, those kind of things, we like having random variables. So NumPy includes many random variables that you can use from, it's about 125 different distribution methods for this. And you might know, like, everybody's seen the bell curve. That's what's called your normal distribution, or your Poisson distribution there. That where all the high top of the curve is, that's where most values should fall. All right, but we've also seen, you might have seen some charts. I'll show you a time series in a little bit. All right, where we can look and see, okay, if we follow that chart, this looks like where that ticker is going. Like we're trying to. Oh, sorry, you missed my hand. So where that ticker is going. All right. Pandas, all right, because we'll go through these libraries real quick here. All right, really good. Typically, one good spot about Pandas is to clean data. It's not like, imagine you enter it into Excel. There's always somebody who puts NA. There's always somebody who puts N/A. Usually, it's a poor intern that has to do data entry, right? One way or another, it's usually a human that gets data into a system, and so with that comes either null values, blanks, incorrect values. Do you call it? Do you abbreviate it? It's Missouri. Do you write out Missouri, or is it abbreviated in there? Or all sorts of things like that. How did they write the time? Did they put the date in what format? All those things need to be cleaned up. So data cleaning, data transformation, Pandas is very good at. Right. So, but it has a frame, like something called a data frame, which is essentially, think of like taking Excel capabilities of the spreadsheet, and that's what it really looks like, kind of, in code, but it has SQL's capabilities of selecting and slicing and dicing and picking records, if you will, rows of data. All right. And so very useful to work in conjunction with SQL, CSV, which is comma separated values, or tab separated values, large data values. Here's the thing, though. Look at that second to last point, though. Everything you do in Pandas is done in memory, meaning that you pull all your data into memory, and then you have to do your analysis on that. So you don't want to do this in terabytes worth of data. You will probably have filtered that. That's part of that whole data engineering pipeline, that you probably will have filtered that out by this time. Now with the age of the cloud, we've got tons of these. It also has some basic visualizations, which I'll show you in just a bit. All right, scikit is kind of like it. I like to call it, it's the Swiss Army knife of machine learning. So it works on NumPy ND arrays, it works on Pandas data frames, and essentially gives you a pipeline for what we call prepping, but or training data. All right, the way machine learning, a lot of machine learning is based, not all, but a lot of machine learning is based on this idea that, okay, let's take a set of known values. A common example that I did with students before is, well, you can tell how long ago I did this. When the Iron Man movie first came out and people were tweeting about Iron Man, if they said, hey, that movie was da bomb, okay, I'm old and I should never use slang. But if they said that, something like that, we would mark that as that's a positive tweet. That's a good thing. People like this movie. If they said in their tweet, that movie bombed, we marked that as that's a negative tweet. People didn't like it. And we give large collections of that. So we manually, in a sense, have to label things. All right. And then we ask the machine, we give the machine a set of new tweets that we've not gone through. And we say, hey, can you figure out whether those are good or bad? All right. That training data was the first thing. We trained the program. We said, hey, look at this data. We said, this is a good tweet. This is a bad tweet. This is a good tweet. Now for marketing, right? If you're Marvel and you want to know, hey, is the movie doing well? What are we doing wrong? Yes or no? Turned out it did pretty well, right? If that's the case, you want to know about that, and maybe, or even if certain marketing efforts, forget that way. So, the question is, hey, were we successful? Is essentially the question we're answering. All right, but all that takes training data and takes splitting it up. And Scikit has tools to help you automatically split up some of that data and read from what you already have, and then guess on new data. Guess is probably not the right word. How about make an educated guess on new data? SciPy is kind of NumPy's twin. And the takeaway with SciPy is it just has this special data type called the sparse matrix. And anybody do any matrix algebra or anything, linear algebra? And if not, don't worry. Good, no problem. But the takeaway is essentially it takes less space and memory than, think of a matrix, right, as this sort of two-dimensional, technically it's a collection of vectors, but anyway, two-dimensional collection of data, right? And so SciPy gives you a way to essentially have that. If many of those elements are zeros, then why take up memory for that? And so essentially it gives you a way to keep that there. But it also has a lot of probability distributions, descriptive stats, test. All right. So remember I said about the math. Yes, you want to learn some math if you want to go into data science. Do you have to know all the math to, I'm a uber guru PhD level? No, not necessarily. Do you have to understand what the algorithm in SciPy is doing for you, especially the SciPy stats submodule? Yeah, you know what it's doing for you and know how to apply it properly, and you'll be just fine and successful as a data scientist, data analyst. All right. All right, now here's the one that most people really care about and want to see in just a second. This is the matrix plotting library. The takeaway is it makes pretty pictures, right? This is what we want. They can zoom and pan and update and play with the visual style on it. And I'm going to show you some tools in a second here. They can be embedded in Jupyter Lab and other GUIs, so whatever you need there. And finally, in Jupyter Lab, we haven't talked about yet, but we'll look at it. And so it's kind of, again, the foundation of where a lot of other graphical packages, including Seaborn, took off from. So Seaborn is essentially the words I hear when people describe Seaborn. They say intuitive, easier, prettier. It has several built-in styles, and it has a different sort of philosophy on how you write the code to create the visualization. But it is still, it's based on the matrix plotting library, matplotlib, but it gives a different sort of high-level interface to that. Okay, we've talked a lot about some of these things, and I know you want to see code, want to do some other things here. So you have another tough choice. So first of all, you got to figure out, you got to understand Python. Second thing, right, you got to go through and say, okay, you got to find, which libraries do you want to start learning? In the order I gave them in the slide, and you'll have the slide that's available, is kind of a rough order to do it. You can skip around a little bit, but yeah, start that way, and you'll start with ND array, get forward with it fairly quickly, and move on to the fancier stuff. There are various tools out there to try some of these things. So for example, the IPython is just short for interactive Python. And essentially it is a mode of working with Python in what we call a REPL. It basically, just think of it. I type a line of code, it gives me an answer. I type a line of code, it gives me an answer. A REPL is short for read, evaluate, print, loop. It's a kind of software tool. And so anytime you have an interactive shell, if you've ever gone to a command line in Windows or in Linux. That's technically a REPL. It reads what you type, it evaluates it as instructions, it prints out the results, and then it loops back and gives you a prompt again to do it again. So we have a shell essentially for Python, if you'd like. You could refer to it that way as well. Jupyter, on the other hand, looks kind of like this. This is Jupyter. And if you can see, and I'll have to clear it. I kind of ran through, I'll go through, uh-oh. Did I lose my connection? No. I'll bring it back. No problem. But while that's going there, but Jupyter, and I can show you some examples. Jupyter is essentially, I'll have this working in the background. A notebook is the phrase that we use for Jupyter, but it is essentially based on it's a web-based interface. So the best way to look at it, it's just doing Python and data science work in your browser. And let me show you a tool then that's kind of the next one you see down a little bit below is at the very bottom, data spell. I'll bring it. Wait for this other thing to set up there. We're now in the, that's always the fun part, is trying to get these to work together. So about Visual Studio, many I have folks, there's always somebody who are working with Visual Studio somewhere or something along those lines. All right, here we go. So this is data spell. Relatively newer. If you're a Java person, you might have heard of like IntelliJ or JetBrains is the company. If you're a programmer, Java programmer, you might have work with Eclipse. We can do plugins there. So here's, for example, a basic. Let's bring up a basic example, and I've got my output showing. We'll run it again. So, can you see that font? It's a little bit. Hopefully, that's not too small. But right on lines 1 and 2. Actually, let me bring up my little marker so I can get up too. But we're gonna get something geekier pretty quickly. But you can notice, see what, because this machine already has installed. Give my pen. This machine already has installed NumPy. All right, my pen doesn't want to. It's fighting with WebEx or webinar. Sorry, there it is. There's it. Took it a while to come up. Okay, but I can mark things up. Maybe. Not. Okay, pause. There you go. Okay. No, it said no. Here we go. Okay. Sorry. One little. They're all enjoying this. I know. Super exciting to watch. There we go. Okay. Come up in a second. Yay. Okay. Sorry. Here we go. So NumPy, right? This is already installed on my machine. So all I'm doing with the tool is saying, go get it. Import is the Python instruction to do that. Now, one thing that we love to do as computer science nerds, and if you don't do this, that's okay. This part right here is just an alias. All right, we just gave it another name so that I don't have to keep typing NumPy over and over again. I can just type NP. Now, almost every data science nerd I know does that. They call it NP. You could call it Fred if you wanted to. You could call it whatever you want on the it's just an alias. But if you don't call it NP, we'll probably look at you and go, noob. We'll know that you're not part of the club. All right, but it's really just a cultural thing. So when I teach you programming languages, when I start with Python or something like that, I like to point out that you can kind of approach any programming language the same way you approach learning a foreign language. So a language that's new to you. So whatever second language you learned, if you did learn one, or if you think about even the way you learned your first language, you probably started out with ABC, right? A, B, C, D, E, F, G, or something along those lines. An alphabet. You learn to make the symbols, right? That's the syntax level. That's the first thing. Symbols, right? Learn to, what are the symbols that we can use? And by symbols in a programming language, though, I don't mean just the letters and or the characters. but also the way they're put together. So for example, this looks like the word if to you. It's a symbol to a programming language. It's a way to assemble a statement for a programming language. All right. Same. So the next step then is just that. How do I put them together? Right. And I can put them together. I can do this. I can say, oh, okay, well, here's what we'll do. We'll put them together and we'll form see Jane run, run Jane run. That's logic. And then the last step, all right, is the second to last step there is what we call idiomatic things. You learn things like I grew up in Missouri, as I say, my mama says Missouri. And so she'll say that you wash your clothes. That's an idiomatic pronunciation of wash, right? But she also, says, it's raining cats and dogs, and it's dogs. You gotta say it like that. All right. So that's an idiomatic expression. Now Python has some things I hate in a programming class saying, well, that's just the way we write it. But on occasion, if you take in another language, you see that, right? That's just the way we write it. Then the last thing, if you were learning a foreign language, is you usually get really, when you get advanced, you learn literature, right? You learn what's out there, AKA libraries. See, it's natural progression of things. Is right. It's the same way we learn a foreign language, the same way we learn our first language. Is we get more and more in depth like that. It's the same way we would learn the data science libraries eventually in Python. All right. So let's look at these. Okay. So this one's short and sweet. This one's just got a very basic cheesy plot here to show you. So two things I need. I need NumPy so I can hold my little range. This stands for an array range. A range is just a collection of integers, basically. And so it's saying 0, 1, 2. It found out how many there are here. And if you count, there's 6. So it says, okay, I'm going to go 0, 1, 2, 3, 4, 5. That's all it's going to do for me. And then it's going to line them up with 10, 8, 6, 4, 2, 1. I just usually made some numbers. And if you look closely, you can see that there is a difference between this has brackets around it. This has parentheses around it. All right. This is a tuple. This is a list. So once I give this to Python, Python won't let that change. You can't suddenly put, instead of Java, put coffee here. It won't let you do that while it's running. That's what we mean by it's immutable, or it's, you can't edit, you can't change. All right, so a list we can, okay? All right, so if we run this is a extremely short and sweet one. There you go. You can see, eventually I'll kick out. I'll talk about the other pieces while it's working. So right here, remember that I brought in the Python plotting library submodule would be the correct term from the matrix plotting library and called it PLT. And that's what it's doing here is it's saying, oh, okay, use the bar function and set the Y position and the performance. This is the data that I want to make bars. I want them to be aligned on the center of each tick. And then the alpha is the spacing. And so if you put this all together, then for the X ticks, I said use objects, use these. So that's essentially the labels, right? For the Y label, I'll call it usage. It said, okay, call it usage. You can see this is very iterative, right? It's just write out, all right, here's how I want to build this visualization. All right, the actual calculation of the data, there wasn't much to it. It just had to take, a 10 and say, okay, I'll make a bar that's 10 units high. Then I hope you can look at this and go, oh, the title. Now what this is though, the one thing at the end is I need this. I say, well, now show it to me. Now, because I'm using this particular one here, which is called data spell, which is very similar to Jupyter, which for the record, Jupyter is technically sort of a strange acronym. It's Julia, Python, and anybody heard of a programming language called R? All right. And so essentially it's saying, I can use any of these languages to create these notebooks that you see. And so let me show you a more advanced notebook to give this here. But without the show, it doesn't want to come up on the screen, is basically the thing. It just creates the object and the plot, as you will. And I will have to do something with the plot later. Like I might decide to export it to a file or something like those lines. Like I'm going to feed it, I don't know, I'm plotting things for the New York Times. So I give them just a a JPEG. Here you go. Here's a graphic. You can put that in. All right, so let me show you though, then Jupyter, and with a little bit more complicated here. And why are you still file save there? Okay. So this is some interactive examples from the matrix plotting library there. This is actually, you can get this example straight from matplotlib, which is kind of nice. And they'll just run, what this is using is they're running a Jupyter server. And so you can tell that it's just web accessible. It's somewhere in the UK. And I get to get, timing out. See, never work live. So what happens? I was doing just fine. And then let's see if we can get it to go. All right, so if you watch really closely, you'll look right about here and you see this funny little asterisk there. What this means is the code in this cell, you can think of them like tiny little mini programs. The code in this cell is being executed right now, but it seems like it's timing here and there. See, it's connecting. I'm having connected issues. Let's go to the UK's internal oil because they don't know what to do about their money. Let me see if I can try one more. Tell you what, give me 1 second. And because, yeah, see, it's going to time. And I want to use a live example. This was working perfectly before I got aligned with everybody. So let me try one more time here to get another one in the background. Worst case scenario, I do have a few other local examples, but they're not as exciting. Try this one more time. And then switch back. While it's busy trying to start up, I'll let it do that. And okay, but I'll let that work in the background. And as soon as it's ready, I'll go grab it. But in the meantime, I have just a few other things to bring up with the slides. So the tools, you've got choices. Yeah, that's up to you. And we can argue about what you like and what you don't, all sorts of things here. But I'll make some recommendations. I tend to like Jupyter. I like the web-based tools when they're working. So let me just leave you with this process here. There's just two little process diagrams I want to show. And now that you've seen some of what's available, right, what you want to do then is okay, working with some of the schools that I worked with here, we kind of came up with a generic, how do you describe the whole data science process? And so the first thing is you got to get data, right? So we investigate, we acquire, we start with a question, so we identify, what's the question we want to answer, we capture any data we have about that, and then we gather, I used to, instead of pool, I used to call that board, we gather everything up and put it all together, and it may not be in a nice organized format, it might not be in the way that we need to use it. So the next phase then is to go to this translate and adapt, right? We take that data and we extract out the stuff that we think is good. We might transform it to a different format or maybe change data types here a little bit, and then we load it into whatever system we're going to use as the back end for this. Okay? And then finally, we want to see what we can find from this. We want to do some explanation. We want to do some presentation. If we find the results, we want to walk through it. So we go through and we sanitize. Okay, one, I worked in security, so like often there are certain things that you can't show to the public. So all right, we may sanitize that and leave that out of this, and then we analyze what we have, right? And these can go in any order. This is, and then finally we need to visualize what's there. And so a lot of times that's that exploratory data analysis phase. Okay. Something happened in the background. There we go. Okay, so now here, all right, I've got finally the matrix plotting library hopefully running again. Let's try it again, seeing how it's going. It says it's connecting. Okay, we're gonna walk through and let's try it. Here we go. So we're gonna run through and we're gonna pull in NumPy. Okay. And NumPy is gonna go through, and if it works, see, it just says, oh, okay, get the little bar, that little one right there. It just means it did it. There's not much for it to do. Each of these cells, and this is the claim to fame for Jupyter, and that is, there you go. So this is a cell, but this is essentially just comment. It's like, it's a comment in code. And so this is, we can document our code. This is the actual code. And this is where the action happens, where something goes and works. And so here we're going to look at like the temperature in Dinosaur, Colorado. And like I said, this is an example that I can point you straight to. So it says, all right, so we load the data. Is that, you see that? I can make it a little bit larger if you want. Maybe it's fighting me a little bit. But right here, okay, you notice that pulling data locally, this is data that's on that same server. So it got pulled in and parts of it were labeled. It says, okay, we set, the date, right? The day of the year, the temperature, all right, solar. And now we've got these two nice little smoothed out versions of the temperature and the solar, on there. So what you end up with, I'll show you, is we're going to plot a time series. And, it looks very similar. So, axis one, axis, so we have two different axes. What an axis is for each of these individual ones that you see down here. So we do two. We can smooth it out. All right, running through. And like I said, I can point you directly to where you can try some of these things on its own. But all of this, you'll notice that there are weird little marks in my code on occasion that look like this. Okay? This right here is a special symbol that says, oh, see? Give me Celsius. So again, those are things that those symbols, see, that we learn in Python to make this. This is how to, so it's showing the solar radiation as we go through here. Now what we've got, see, is just these charts and smoothed out a little bit so they're hourly. So hourly is going to be very jagged because it's very fine grained, right, data. So it's been smoothed out in the orange version that you see there. So you notice that the trend goes really high. See, for the solar radiation, because it's dark and then it's very bright, and then so we smooth that out to see what that looks like over there. So now we can start predicting some ideas of, okay, how hot is it going to be? How bad it's going to be. So we can plot the properties here. And again, this is really just more of a tour here. You notice that these, the day of the year, going through solar radiation. And finally at the bottom, load some other data here. All right, it's for land surface temperature around the globe. Same plot. And you notice again, using these axes and figures that it set up. All right, so I know it's a lot to get through and I'm running, to the end of my time. There's never enough time for all this. Let me just leave you with a few things here. All this is available for you. Smooth just means, okay, so normally what smooth means is that if I take data points, let's say I have, Monday, Tuesday, Wednesday, Thursday, Friday, right? And I have 8, 7, 5, 3, 2, whatever it is, okay? When I were to draw, if this was a bar chart, see, there'd be an 8, then there'd be a 7, then there'd be a 5, and then there'd way down here be a 3, and here be a 2, right? So it looks kind of, so smooth. What if I had done this many weeks, okay? That this was, I did this over, maybe I had hourly temperatures in here. So I had 8, 8, 7, 8, 6, the hours going across there. Well, then we see that's what we've done is rather than making it go 8, 8, 7, well, we're just going to smooth that out and call this an 8. We kind of think of it like to get that curve. Now, it would have been better probably if I were going to do this. I would actually give you like the curve, the trending curve over there on there, because what that helps us do is figure out where the next temperature, like you can look at this up here. And again, so much chicken. So if I were to, this is 2021, okay? So this data only went to 2021. If I gave you, and that's September, right? So let's say I gave you right here. So now it's going to go into 2022. You can kind of guess where this line is going to go because you've got the pattern from it. Smoothing is just roughing. It's like on sandpaper. When you take sandpaper to wood, wood's got a lot of fine grained bumps. You smooth it so that the surface is a little bit nicer on the curve. That's all it is. But there are several mathematical ways to do that. But that's all they did with this. So, and this is actually just public data. This is NOAA data. So you notice that they did hourly, and then they kind of smoothed it out to more of a weekly thing. What does it look like when you take that data and establish it over a week? Usually what we do is we get bigger in scope. What I have for you, is a few other things before we go. It's a lot to try to cram it into an hour. All right, so hold on to these slides. You have my contact information in there. Let me provide one last little how this fits in the big pipeline. And so this is based on a couple of different things here. In a sort of you hear words like engineer, analyst, scientist, and so this here web age, this is sort of our definition of where that fits into the scope and what you might be doing and how that fits in with an actual organization's data system, right? And so, the data engineers are putting things in the databases, and the data engineers often clean and that, and the data analysts are probably trying to find initial sort of findings and reports. Data scientists, get to towards the other end. Remember, I talked about building predictions, so building a model using training data, say, or doing analytical modeling. So analytical modeling, it would be using that training data and coming up and, okay, all right, now I have a model of what this thing we're studying looks like the stock market, real estate market, whatever. And this is what we think is going to happen based on the data we've seen. And so how it all fits into the big picture is what we have for you here. In our courses, we go through this, we kind of use this as a touch point to go back to. I know I'm running 1 minute or so late. The demonstrations kind of came as we went there. There are some classes that if you look on our schedule, we have things like mastering Python programming. That probably be a good place to start just to get Python. We do have a machine learning and applied data science with Python, among others. There are others. If you're curious as even to where to go, if you don't know where to start, my email is at the beginning of these slides. And when you get those slides, feel free to send me an email and I can point you to here's some of the best places to look, and here's what your organization does. And one other nice claim to fame for us is that we can integrate with your IT data science people and come up with sort of a customized plan. Here's what you need. From that could be a day to, for example, there's a client that we do a 6-week boot camp for their new hires where we show them that company's way of how they analyze data, how they build their products, and how they go. And so we build employees for them, basically, is the plan. So feel free to take a look at that. I know there's time. I can stick around a little bit. I know many of you probably, this is your lunch hour, so you're probably heading someplace else. Anybody, has some other questions that I didn't get to or want to take a moment, feel free. Otherwise, the recording will be up there soon and along with the slides. If you need to contact us, it's also in there as well. All right. And I thank you for your time and to give up your lunch. Hopefully you got to eat a little something while we're gapping anyway, but you can always get a hold of me. We can go from there. All right. So otherwise, have a great one.